So now if we have the horizontal length as h, if we still start with our point A, if this is A, then this x-coordinate would be A plus h. And if the y is whatever f of A would be, now the y over here is f of A plus h. And the same idea holds while we take this y value and subtract this y value, and that would be our rise. But now our run is just one value of h. And now the limit that we want is if we want to take this point here and slowly make it approach this one, what's going to happen to our h value is it's going to approach 0. So another definition is we could take this definition, this slope line, and say formula number 2, let's make the limit as h goes to 0. And again, this is still your rise, and this is your run, and there's a typo here. This should be h. And of course, we have a problem again, because if you plug in 0 for h, you're dividing by 0. So we're going to have the same kind of mathematics that we need to do. And of the two formulas, this one tends to be used more. We'll do the new formula together on this one. Then afterwards you can do the other formula, and you can decide which one you like better as far as how they simplify. They'll both give you the same slope. So we'll split our page in half here. Let's use the new formula here for slope. It's the limit as h goes to 0. According to the formula, you need to do f of a plus h. Okay? Our a value is right here, because this is the point. This is f of a. And according to the formula, we have to do f of a plus h, which will be f of 3 plus h. Minus, f of 3 over h. And this is where I think this formula is a little bit messier, because what is f of 3 plus h? That would be plugging in 3 plus h where the x is. So you would have 3 plus h all squared minus 4 minus, and f of 3 we already know is 5. All over h. I'm going to pause right here, because if there's a place where you're going to get a little bit confused in this notation, it would be at that step. So are you okay with the fact that f of 3 plus h is equal to this? Take a look at the equation. Might help over here if you think of this as f of x equals x squared minus 4. What have I done? I've replaced, right? Here's where my x is, here's where my x is. So I've replaced the x with 3 plus h. So in x squared minus 4, I have to replace the x with 3 plus h. So that's reviewing your function stuff. Once you see that, the rest is just algebra. Be careful not to just square the 3 and square the h, because 3 plus h squared is 3 plus h times 3 plus h. You'd have to do all the arrows, and you would get 9 plus 6h plus h squared minus 4 minus 5 all over h. And just like the other methods, nice things happen. 9 minus 4 minus 5 is 0, so you just get 6h plus h squared. On the top, 6h plus h squared, you can factor out an h. Those h's cancel out. And now we can finally apply the limit. So now is the first time that you don't have to write that little limit thing. Plug in 0, and you get a slope of 6. Did it ask us to find the equation as well? Find the equation of the, oh, they just asked us to find the equation. So now that we have the slope, we could find y equals mx plus b. You know that your slope is 6. We have a point which was 3 comma 5. So when x is 3, y is 5. That gives our b value as negative 13. And so our equation of our tangent line is 6x minus 13. Okay. Looking at our other technique, can I slide it up, or do they need me to go back down for a second? Anybody need me to go back down for a second? Yeah? Okay. Sorry. Good. So looking at our other technique, which was that the slope was the limit as x approached a, and our a value is 3 in this case, because we're finding at the point 3 comma 5, of f of x, which is just x squared minus 4, minus f of 3, which would be just 5, over x minus 3. We get now you can apply the limit, you get 6 as well. I find when you're dealing with specific points, as we were in this case, 3 comma find the slope at that point, that the formula that we learned first, the algebra is actually easier. You didn't have to deal with the thing that I highlighted here, which is where you're going to make your algebraic mistakes. Okay? You'll find, though, that when we're dealing with generalizations with the actual formula, that the second formula will be a lot nicer. When we want to find out what are all the derivatives for x squared minus 4? What is the equation for all the derivatives? And in this case, you're going to find out that the equation for all the derivatives of x squared minus 4 is just 2x. And when x is 3, what's the slope? 2 times 3? 6. If you wanted to find it in another point, if you wanted to find it at the point 9 comma 77, then what's 2 times 9? 18. The slope would be 18. And it'll be that quick for us to figure it out. That's what we're going towards, and we're going to find that this formula that we just learned works better in those cases to find the generalizations.